Good morning, everyone. Hope you're all doing all right. So today we're going to talk about Unit 7, Lesson 2, which is graphing exponential functions. It's going to be split over into 2 lessons just because there's a lot to go through. You will need a graphing calculator for today. So I talked to Christy Morgan, who's our tech person at school, and on your Chromebook, they downloaded a TI-84 graphing calculator. I'm really not sure where to find it since I don't have access to a student Chromebook, but you will need a calculator of some sort. So I'm going to be jumping back and forth between this calculator and then my normal presentation. I believe you're going to have something like this where you'll be able to graph and go from there. You're also more than welcome to use Desmos or a different graphing calculator, but you will need a graphing calculator to go through today. All right, so today, exponential functions. Here's what your parent function looks like. It's f of x equals b to the x. So if you notice, your b is going to be a number and your x is your variable. So when this b number is greater than 1, it's an exponential growth, and it means your numbers are increasing, which is what you're actually noticing right now with this pandemic that's happening. We have an exponential function because our numbers are rapidly increasing daily. We're hoping to eventually see it on the decrease. And that means your b value is going to be less than 1, exponential decay, decreasing. So all of your graphs today will have an asymptote, and that occurs at y equals x. So if you look at this original equation, there's no k. Oh, I think I said y equals x. This should be y equals k. Anyways, but there's no k in this equation. Technically, your k is somewhere over here that you add or subtract, which is kind of what tomorrow's lesson's about, but I'll explain where to find it. Quick reminder, an asymptote is a line that a graph gets continually closer to but never will cross, and once again, it should be dashed. So what we're going to do for step 1 is we're going to create an XY chart. And then since none of these have any changes, I'm going to go from -2, -1, 0, 1, and 2 to get my numbers. So we are going to go and open up our calculator. Okay, so in the calculator, you're going to go to y equals. I would clear out anything that you have in here just so we can get the picture of our graph. And we're going to do 2 raised to the x. Okay? From here, we need a table of values. So I'm going to do second graph. Now, once again, you could pick any numbers, but if you notice, if I were to choose -8, I'd have to plot a point at 0.0039. I don't really know where that point is. So we'll talk about how to find these numbers, but I need to see from -2 to +2. So starting at -2, I'm going to go back to my paper. I'm going to write down my points. So at 0.25, 0.5, 0, 1, 1, 2, and 2, 4. So this is what you should have in your table of values. Now, one of the first things that you should be able to find on here is your asymptote. The asymptote is going to be a horizontal line, so it should say y equals. And we're not adding or subtracting anything after this function, which is where you find your k. That means my asymptote's at 0. So I'm going to go through and draw in my horizontal asymptote at 0. From here, we can go through and plot our points. So I'm going to go to -2.25, -1.5, 0, 1, 1, 2, and 2, 4. Okay? You're going to go through and connect your dots. So since we have that asymptote, this left part of my line should never cross below that asymptote. And if you notice, my arrow goes to the left forever over here, while this arrow goes up. Okay, so this is an exponential growth because my b value, which is 2, is greater than this one up here, so it means we're growing. So my y values are getting larger. For your domain, my arrows are going to go left and right forever. Although this is going up, it's also going to the right. So that means my domain is going to go from -infinity to +infinity. Your range, as a reminder, goes from bottom to top. My lowest or my bottom number is at 0, which you cannot get to, so it's just a parenthesis. And then you go up forever, which is going to +infinity. So once again, it's a parenthesis, not a bracket, because I cannot reach 0, so that's where my asymptote is. I'm sorry, Leah, I just kicked my dog, guys. Okay, so when x is going to +infinity, this is asking about my right arrow. Where's my right arrow pointing? Well, that right arrow is pointing up towards +infinity. This one is where x is approaching -infinity, which is my left arrow. But the y value that this is approaching is my asymptote, which occurs at 0. So end behavior will always have one infinity sign and then the asymptote. These will change depending on the function that you have, but you should never have two infinity signs. Last but not least, you have to find your Y-intercept. Your Y-intercept is when x is equal to 0, and you should usually be able to find it in your table of values. So in this case, my Y-intercept is 0.01. Okay, let's try another one. If we look at number 2, okay, so on number 2, we have this 3 right here, which means we're going to have a growth. So that means my function is going to go up to the right again. We need to create a table of values. And I'm going to do the same ones of -2, -1, 0, 1, 2. Quick reminder, you can pick any points to go in your table of values, but I am not shifting left, right, up, or down. So these are the 5 easiest points that you can find. The last thing that we can do before we go back to our calculators, we can find the asymptote. Your asymptote is a number that you're adding or subtracting outside of this function, which in this case would be at 0. Okay, so let's go back to our calculator. Okay, so in my calculator, I'm going to go to y equals. I'm going to clear out what's in here. I'm going to do 3 raised to the x. And then once again, you hit second graph to reach your table of values. Now, your points are a little bit weirder, but it's fine. You can still mark them down. So for -2, you're going to have 0.11. -1, you're at 0.33. 0, you're at 1 again. 1 is 3, and 2 is at 9. So when I go back to my paper, this is what you should have written down. Okay, and let's go through and graph it. So once again, here is my horizontal asymptote at 0. Plot your points. They're basically in the same point or spots as they were last time. The only difference is I'm growing exponentially faster. So if you notice, this is a steeper graph, whereas this one is a little bit wider. And now we just find the rest of our pieces. Your domain is always going to be from -infinity to +infinity because I have an arrow going left and right forever. Once again, it's going up, but it's at an angle to the right. Your range, my lowest y value occurs at the asymptote, and we do not include that value, so it's a parenthesis. And my arrow goes up forever, which means we're going to +infinity. Okay, from here it says when x is going to +infinity, which represents my right arrow because those are the values to the right. My right arrow is pointing up, and that y value goes to +infinity. My x going to -infinity is my left arrow, and my left arrow is going actually to the left, but it's approaching my y value of 0. Once again, 1 goes to infinity, 1 will go to the asymptote. Last but not least, you're looking for the x-intercept, which is x is equal to 0, and in my table of values, it occurs at 0, 1. Okay, let's flip the page. Let's do a couple others, make sure we got it. So if we look at number 3, your 1/2 is your b value. That b value is less than 1, so we have a decay. So it's going to be slightly different in terms of the way the graph looks, but finding everything is the same. We're going to start by writing down our XY chart. And I will once again be using -2, -1, 0, 1, 2. You find your asymptote the same way. There's nothing adding or subtracting outside of this function, so that means it's going to be at y equals 0. When we go back to our calculator, you're going to go back to your y equals, clear out anything that's in it. I'm going to do parentheses, and you can either do your function as a fraction, so I can do alpha x, or you could do alpha y equals and get your fraction. You can also just do 1 divided by 2 as well. However you want to do it, but you need to make sure it says 1/2 raised to the x. Very important that you put it in parentheses as well. Once you have it typed however you want, go to your table of values. Okay, and so at -2 we're at 4. -1 we're at 2. 0, 1, 1.5, and 2 is at 0.25. Okay, let's go back to our graph. Almost forgot to toggle between the two. Asymptote's at 0, so let's draw on that line. Plot our points. We're going to go to -2 up 4, -1, 2, 0, 1. So what you're going to notice is that this graph looks almost identical to the one that we did on the previous page. It just goes in the opposite direction because my numbers are starting very high and now they're going very low, which is what a decay means. Your domain for growth and decay is the same. I have an arrow going left and right forever, which means we're going from negative infinity to positive infinity. Range. The lowest number that I reach is my asymptote, which is at 0, but once again, we do not include it because it's an asymptote. And then my other arrow goes up forever, which is reaching positive infinity. End behavior stays the same. I want to look at my right arrow. When x is going to positive infinity, that's the right. My right arrow this time is not going up, it's going to the right forever, but it's approaching the asymptote, which is at 0. Because my arrow is going down, technically, but it will never get lower than this line. That's why we're at 0. Whereas my left arrow is this guy that's pointing up forever, which means we're going to positive infinity. Last but not least, your Y-intercept is when x is equal to 0, which in this case is at 0, 1. Okay, let's do one more, make sure we got it. So looking at this, 2/3 once again is less than 0, so we have a decay. We're going to do an XY chart. My asymptote is at 0 because I'm not subtracting anything outside of it. Let's go back to our calculator. Go to your y equals, clear anything that's in there. Once again, you can do the fraction button. You can do what I'm doing. You just need to make sure that you have your 2/3 written in there. And you're going to raise it to the x. Okay, I'm once again just going to go from -2 to +2. Since it's not the greatest of numbers, they're just the easiest ones to graph. So -2, we're at 2.25. -1 is at 1.5. 0, 1, 1, and 0.67. And 2, you're at 0.44. Okay, let's graph it. -2, 2.25, -1, 1.5. Let's see. So if you notice, this one is a little bit less dramatic because it's 2/3, so it goes a little bit more at an angle. Hopefully you're a much better grapher than I am. Domain is always the same, negative infinity, positive infinity. Range, my lowest y value is at my asymptote, which is at 0, and we go up forever. So we're going from here up. So I'm going from 0 to positive infinity. My right arrow is approaching the asymptote, which is at 0, whereas my left arrow is pointing up forever, which is going to positive infinity. And my y-intercept is where x is equal to 0, and that's at 0, 1. Really quick on number 5, I'm just going to make sure we can figure out whether this is a growth or decay, and then you're done for today. 5/2 is the same thing as 2.5. 2.5 is greater than 1, so this one's actually a growth. And I just want to make sure that you're not getting into the habit of whenever you see a fraction, it does not automatically mean a decay. You just need to see whether or not that number is greater than 1 or less than 1. Tomorrow I'm planning, or not tomorrow, what's today? On Thursday, I'm planning on doing a conference on Canvas, and it's just our voices, but it's a time that if we want to all meet and you have questions you need answered or you just need anything clarified, we're going to do that on Thursday. So you'll go to your Canvas page and then you'll go to a conference and you'll see that I'll have started one. I'm trying to do it around 10:30ish on that Thursday. Hope to see you there. If not, if you have any questions, feel free to email me, and have a good day, guys.